Hi everyone, this is a workshop for FOSDEM 2022 on AI pathfinding in FXGL. So if you have not used FXGL before, it's a game engine that uses JavaFX as the rendering pipeline and also follows quite a lot of JavaFX architecture, and in general you can swap a JavaFX application with an FXGL application and none of the tools will complain. So we're going to talk about game AI and specifically about how to implement AI pathfinding in FXGL and what kind of API and properties, features FXGL offers in that area. So first of all, just a quick introduction to game AI. If you've not done any game development before, we tend to focus on three areas of game AI, and these are decision making, so how to get to the overall goal in the future. So how do I plan ahead? What are the steps that I need to take to get to my goal? So that's what AI thinks, I suppose. And then we have behavior. What kind of things do I need to be doing now in order to meet my goal? Typically, it's the short-term goal. And finally, it's pathfinding, how to get from one location to another, typically without colliding into any of the obstacles. And then we need to define what obstacles are. So suppose you have a player here and AI here, and the AI agent needs to get to the player without going through the wall in between. These kinds of questions we're going to be asking today, and most importantly, trying to solve using FXGL. And that should be everything you need to know really in terms of the context in which we're working. So first of all, how you set up FXGL. I've done this many times in various different videos. If you haven't used FXGL before, it's essentially just a Java library. So from your perspective in terms of project setup, you just add a Maven dependency or a Gradle dependency, and that's everything you need to have. And that's it really. We're using Java 17 with FXGL 17, which is the latest version as of January 2022. So your class needs to extend game application, override initialize settings, and your standard kind of public static void main that calls launch. So if we run this file, it will give us an empty window with nothing in it, and that indicates that everything is correct, and you'll have a bunch of information printed to the terminal. There is a warning there that says that you don't have a module info.java, but that's fine for the purposes of this workshop. Right, so let's get some game objects on our screen in our game. You would normally use the entity builder class to build entities in using Fluent API. So what we want is a view with a bounding box, which is going to represent our player or our AI, I suppose, since we don't necessarily need to be controlling it. Build and attach. So if we run this now, we should see a blue square 40 by 40 in our game. So this is our game object, and game objects in FXGL are called entities. Let's have a reference to this entity. We'll call it just AI, or I suppose agent is a better word. And now we have a reference to our agent, which we can use in the entire class. Right, so we've got that. Now we want to be able to click and move, and then we're going to add an obstacle, or we can generate dynamic obstacles at runtime, and then we'll make, or rather we'll ask the agent to figure out a way around these obstacles. So the way you add behavior or data to entities is you use components in FXGL. You can see a bunch of pre-built components. The one that we want is cell move, because the game is divided into cells in our case. Cell width could be 40, I suppose, just to match the player size or the agent size. And then pass the speed with which the agent will be moving. And we need to, just to give an idea of what the world looks like to us, because to the agent already will have knowledge. But for us, it's much easier to perceive how the whole thing works if we have something to look at. So how about we populate the world with squares, so that we can see what the cells look like. And we'll need to set the dimensions of the game to something like 720p, so it's nicely HD. And now we can just populate all of this with squares of, we can use color white for now. We're going to identify the squares that cannot be walked on using color red. And then what we could do is create, use stroke around a rectangle. So this is just normal JavaFX API, so nothing new there. And then, because the world is now going to be populated with these entities, so every single cell square that you can see now on the screen is a single entity game object, which means we can click on it and we can make our player or our agent move there by adding just a little bit of code. So we need to make sure that our agent is added to the world after, so that it is displayed on top of the cells. Alternatively, which is probably the easier option, is to set the Z index, so the Z sorting order, which means the cells are going to be drawn below the agent. By default, Z index is 0. So we can see our agent there now. Right, let's implement the moving bit. So I'm going to be clicking on these cells, so something like on click, or specifically I want the view component, add event add on click handler, which gives me a mouse event, a JavaFX mouse event, so it's very convenient. If event is primary, then we're going to take our agent, we're going to get its cell move component, which we attached over here, and we're going to move to that cell. And X and Y are nicely going to be read from here. they're not final, which is why this is complaining, and this is currently in a lambda. So let's create our final x and final y. And let's try that. Okay, that is not doing anything. Let's check the type of the button that is being pressed, because that should be one way to check if the button I pressed was left click or right click, because I'm saving right click for turning the cell into a red cell, the cell that we cannot cross. So the reason it's moved in a very weird fashion is because it thinks that its center is in the top left, which is what it is by default. So we're going to change that very easily by just saying set anchor from the center, and we will need the bounding box for that, which is why we're using view with bounding box. It will generate the dimensions which will match the view, which is 40 by 40. It will set the anchor from the center, meaning 2020 as a point will be the center from which it calculates its various information for movement as well. So now it nicely just goes into the cell that we wanted to go to if I click on that cell. Now, if we were to place an obstacle, so I'm going to use the right click over here to change, first of all, the color to red to indicate to us that it's not something that we can cross. But I'm not going to do anything to the model of the game, to the world, and you'll see what the issue is. So I can do this. Imagine it's a wall, and if I click here, you can see that the agent just goes through the wall. So not ideal. To make it work, we will need a representation of the world that is the A star grid. This is primarily what we use in order to tell the agent which cells are occupied and which cells are not. Let's create our grid. Typically, you don't need to create it from scratch if you already have a game world, such as maybe you've created a tiled map for the game as a level, and then you can pass it into the game, and then you can pass it into an A-star grid. A-star grid is essentially just a two-dimensional grid of cells. It's called A-star because the algorithm that we can be applying, that we'll be applying on it, is called the A-star pathfinding algorithm. Width and height are determined by the number of cells. So it's something like this. And then after we've added the cell move component, which tells the entity how to move in a cell-based fashion from one cell to another, we can add a star move component. So you can see how components very scalable. They scale horizontally, meaning you can just add one component on top of the other, and they're not going to interfere with each other because the scaling is not vertical, as in there are no subclasses or superclasses. All components are at the same level, and they don't normally interfere with functionality of one another. A star move component, and it takes the grid because it needs to know what the model looks like. And now we're not going to use cell move component to move it. We're going to use a star move component to move to the cell. So note that I've replaced this bit of code here. And instead of just moving there, it will now move there in a kind of smart way. It will use the AI pathfinding algorithm, which in this case is the A star search, to go to that cell. And here, when we make the cell red, we also want to update the grid, the model. And we're going to say, so what does it take? Get final X. So we want to get that cell, and then we want to set cell state to not walkable. There are only two states. Walkable means you can cross it, and not walkable means the agent cannot go through that cell. So imagine like rivers in the game, or small ponds, essentially any tile, any cell that you cannot cross. So we can move from here to that cell. Again, there are no changes, although we're using a different technique now. And now let's add a wall in between. So you can see that the agent no longer follows the straight path, which is the quickest path, but within the context of this obstacle, it is no longer a valid path. Therefore, it cannot be used. And we can just play around with this now because everything is set up. That is pretty much the end of the workshop. You now have all the information necessary to be able to build FXGL games that include AI pathfinding. Let's just create some very interesting combinations. Like to get to this point, you'll have to go around, and to get to here, you'll need to go all the way around. And typically the return result from the A-star pathfinding algorithm is the shortest path, or I should say a shortest path, because we don't know how many paths exist of the same size. And you can also cancel movement during the actual movement. So you can define a different cell to go to, and the pathfinding algorithm will recalculate the movement as necessary. I'm just trying to build somewhat of an interesting path to get to. And then if you click on a cell to which there is no path, then the returned, well, essentially won't do anything. In terms of the low-level implementation details, the return path is a collection, as in a Java collection, like a list. And the return path will be simply empty. Not null, but empty, meaning that